Math 1, practice 4.2.2, solving problems given functions fitted to data. So, race car tracks vary in length. The race car driver records the time it takes him to circle various tracks. So first thing we want to do is create a scatter plot here, with this data set, okay? So once again, we want to use our calculators, right? So we want to go to New Documents, add a list and spreadsheets, and then we're going to call one time and 1 minute, or not minutes, track length, and then we're going to type them in, so I'll do that. So here's our scatter plot on the calculator. Okay, as we can see, looks like it's a pretty strong correlation. So would linear or exponential? Well, definitely it's going to be linear because it looks more like a straight line, right? So it'd be linear. Now it wants to know what line would work better, 2.3x or 3.3x. So I'm going to add that into my calculator, and we'll see which line works better. So if we look at these two lines, the bottom one is y equals 2.3x, and the top one is y equals 3.3x. So I think it's pretty clear that y equals 3.3x is a better fit for our data. Follows the dots much better. So then we can use that one to help us answer 4 and 5. So how long would it take someone to circle a track that is 1.8 miles long? Well, the length is our y variable, so I'd go 1.8 equals 3.3x. So we divide by 3.3, and x would equal we get 0.545, so basically 0.55. Now, that's not 55 minutes, that's a little over 0.5. 1/2 would be 30 seconds, right? Because these are in seconds. Or minutes, yeah. So, it would be about half of a minute, okay? So, now 5 says, it takes a driver 0.6 minutes to circle a track. How long is the track? So here we go, y equals 3.3 times 0.6. And whatever 3.3 times 0.6 is, which is 1.98, so it's nearly 2 miles long. Okay? So that's how we use that line of best fit to help us make predictions and understand what's happening. Okay, now let's take a look at another one. So the value of a car decreases over time. Bethan, whoever that is, this dude, Big B, buys a car for $20,000. Each year she determines how much her car is worth. She records the value, so it's got to be Bethan if it's a girl, right? Anyway, she records the value of her car in the table below. So let's create a scatter plot and decide linear or exponential, and we've got some equations to check. Okay, so I'm going to put all that together on one. So if we look at this, here's our points, here's our scatter plot. So we should notice it kind of has that curvature to it, so it's definitely going to be an exponential. Now, here's our first equation, the one right here, and it's not even near it, right? So we know it's not that one, so it's got to be this guy. Okay, which is this one right here. We see how it's modeling the data. So, Beth Ann wants to sell her car when it's worth approximately $9,000. How many years should she wait to sell it? Well, X stands in for years, Y for the price. So I'd go 9,000 equals 19,000 times 0.9 dx. So first I divide by 19,000. Okay. So in my calculator I go find my calculate screen. And I go 9,000 divided by 19,000. And that gives me 9 over 19, but we want the decimal, right? So about 0.47. So 0.473684 equals 0.90 to the x. So now I've got to figure out what value of x will get me to that. Okay? And looking at my table, we can see that 6 years it's at 10,000. So So I could go 10,000 times 0.9. Might be an easier way. And that gets me to 9,000. So it'd be 7 years. So what I could have done is just tried out 7 in here for x and go 0.9 to the 7th. And I would have ended up with roughly with this decimal right here. So 7 years. Okay. How much will their car be worth in 12 years? Well, here, this is the easier one. We go y equals 19,000 times 0.9 to the 12. So that's much easier to type into my calculator. So I go 19,000 times 0.9 to the 12th. And it gives me about 5,366.16. And there we go.